All right, today we're going to pick up with more work on three-dimensional figures. We're going to work on today some application questions where you have to find either surface area, volume, or maybe even both and apply them to a situation. All right, the first thing they look at, and I've seen this on several different tests, is it's kind of a visual thing and a depth perception, was where they give you a drawing like the one you see here. It's made up of 1 centimeter cubes and ask you to find total surface area and volume. We can use formulas. We're also going to do some counting to make sure we get everything taken care of. The first thing I'm going to do is look at the surface area and understand that there's really two sets of front faces, if you will. There's this front face that I'm tracing right here that's 4 by 4, and there's a face here that's facing us. I'd call it front face. That's 2 by 8. So this surface area is 16 square centimeters. This surface area is 8 square centimeters. Okay, the back you got to understand is completed by a 1, 2, 3, 4, 5, 6 by 4 shape. Okay, and it's going to be 24 centimeters squared. If you notice, the front's also the same. Okay, the right side of our shape here is really made up of two different rectangles, if you will. Actually, it's just two squares in this case. You have this side square here that's 4 by 4. You can see there's 16 square units here. And then this one up here is 2 by 2, and that's 4 units squared. Well, the left side is going to be just like that. So 16 plus 4, the left side is going to be 20 square centimeters, just like the right side. Okay, that leaves the top and the bottom. If you look down at the top, you have this rectangle that's 2 by 4. This rectangle is 2 by 4. So the top's made up of 8 plus 8, or 16 total centimeters squared. The bottom is 4 by 4. You can kind of see that here. And the bottom is going to be 16 square centimeters. So remember, total surface area is going to be the sum of all of the areas of the faces. So I got 24 for the front, 24 for the back, 20 for the right, 20 for the left. Top and bottom are both 16. That's going to give us a total of 120 centimeters squared for the surface area of this shape. Okay. Now for volume, I'm going to take it in two parts. I'm going to find the volume of the bottom prism. Okay. And this is actually a cube because it's 4 by 4 by 4. And then I'm going to find the volume of this top uh, rectangular prism, which is 4 by 2 by 2. And then I'm going to add their volumes together. Okay. So the bottom cube here, area of the base is 4 by 4, height is 4. This rectangular prism, area of the base is 4 times 2 times the height, which is 2. Pretty quick calculations there. The volume of this is 80 centimeters cubed. So if you were to try to count all of these cubes, there would be 80 of them. Okay. You could go through and actually do that. It takes some mental, some imagery, I guess, and some depth perception to be able to see it all. But there are 80 cubic centimeters here in the drawing. Okay. This second question is just getting you to see the difference uses between surface area and volume. So this one just says that we have this rectangular prism that's a juice box, 6 centimeters by 2 centimeters by 11 centimeters. And the first thing they ask us to do is define the surface area and volume of this box. Okay. So surface area, remember, is the sum of the area of all the faces. So 6 times 2 is this bottom rectangle, and it's also the top. So I take 6 times 2 and double it. That gives me 2 of the 6 faces. The front face looking at us is 6 by 11. There's a back rectangle, 6 by 11, just like it. So I'm going to do 6 times 11 and double it. And then the side here is 2 by 11. This side's also 2 by 11. So I'm going to take 2 times 11 and double it. So these twos in the front represent, all the faces now are accounted for because there's 6 of them. And then doing the math here, we're going to get 200 centimeters squared is the surface area for this juice box. Okay, the volume of it is to do the area of the base times the height. So the base shape, the way it's sitting, is 6 by 2, and then 11 is the height. So 6 times 2 is 12, times 11 is 132 centimeters cubed. Okay, all right, so looking at a couple of applications. First of all, it says the juice box is going to be filled with juice, obviously. Which measure would be the best used to find the amount of juice it holds? So when you're going to fill something up, you're going to find its volume. Okay, so we want to use this 132 centimeters cubed as a guide for how much juice will be used. The second question is we're going to coat this box with wax, make it so it doesn't leak. Which measure would help the manufacturer know how much wax to buy? Well, if you're going to coat the outside surfaces, then you're talking surface area, obviously. So this 200 centimeters squared is the one that the manufacturer would be most helpful in having. Okay. Another application. So a company makes storage containers with sheet steel walls. The containers are shaped like rectangular prism. If the company has 672 square meters of sheet steel available, how many storage containers can be made? Okay, so here's the storage container. And so they're talking about the walls of it. And so since we're talking about the surface of the walls, we're talking surface area. So we need to find the surface area for this rectangular prism. So again, we got to find the areas of all the faces and add them together. So 6 by 6, that's the bottom. And then the top's just like it. So 6 times 6 times 2 gives me the top area and the bottom area rectangle. 4 by 6 is this side. So 4 by 6 is also this back side. So I got two of those. And then I did 6 by 4 is the front face and 6 by 4 is the back face. So I got two of those. Okay. So this will help me find my total surface area. And it's 168 meters squared. So each container that we build is going to take 168 square meters of sheet steel. Okay. The company says it has 672 meters of sheet steel available to it, and it wants to make these containers. Each we're going to take 168 square meters of material. So 672 divided by 168 is 4. So right now the company has enough sheet steel to make 4 of these containers. Okay. Little application of surface area. Another application of surface area, kind of similar here. So we got a company now that's making water tanks in the shape of cylinders. The tank's going to have, it's going to be 4 foot high and 10 feet for diameter across. It's going to be made from metal, and we're talking about the top and the bottom. So we got to get the whole thing made up here. If the cost of the metal to make this one container is $9,325.80, then how much did we pay per square foot for the metal? Okay. So again, if we're making the container, then we're making the surface of the container. So this is surface area. Surface area for a cylinder, 2 pi RH plus 2 pi r squared, formula that you have. Okay. Plug in what you know. Actually, let me take a step back here. In the formula, we're using radius, not diameter. They give us diameter. So let's quick convert that to a radius. So we want to use radius of 5 here in this problem. Okay. So plugging in our values, 2 times 3.14 times 5 times 4. 5 is the radius, 4 is the height. 2 times pi times radius squared, 5 squared. Okay. Now it's a calculator exercise. Make sure we're multiplying it all out. Notice in the instructions it said don't round. Use 3.14 for pi and don't round. So here's our unrounded answer right here. The surface area for this container is 282.6 square feet. So it's going to take us 282.6 square feet of metal to make the cylinder. Okay. So if it costs $9,325.80 for all the steel, and it takes this much steel, then dividing the total cost by the amount of square foot will tell us the cost per square foot. So it's going to take it's going to cost us, the metal must have cost us $33 per square foot in order for us to build this tank and it to cost this much money. Okay. So more applications here. It says find the length of the cube if it has a volume of 551 centimeters cubed. If necessary, round your answer to the 10th. Okay. So we know the volume of any prism, including a cube, is area of the base times the height. Now, the unique part of a cube is every side length is the same. So the length, the width, and the height, they're all the same, S. Okay, so if you were to start working through this formula, area of the base is side times side, and the height that I multiply is also a side, an S. So S times S times S. So the volume for a cube is actually S cubed. Now that's going to help us here because they tell us the volume is 551, right? So I put 551 in place of volume. It equals S cubed.
So we have to figure out what number times itself 3 times equals 551. Well, a better way of doing it is to use the algebra that you know, which is to cancel out something to the third power. We take the cube root of it. So the cube root of s cubed will cancel out the cube and give me the s. So I got to take the cube root of 551, and that's about 8.2. So 8.2 times 8.2 times 8.2 is really close to 551. It's not perfect. You can see that I've rounded it. That's my approximation symbol there. But that's how we could find the missing side length here given volume. Okay, so that's a volume type question. The last example I have for you is a company makes concrete bricks shaped like rectangular prisms. Each brick is 10 inches long, 7 inches wide, and 5 inches tall. They use 14,000 inches cubed or cubic inches of concrete. So, how many bricks did they make? So, take our rectangular prism and throw the dimensions in 10 by 7 by 5. Okay. What it takes to make a brick is you got to fill up the shape. So, this is a volume question. Okay. So, what's the volume of this rectangular prism? Well, it's area of the base times the height. Base shape is a rectangle that's 7 by 10. The height is 5. So, quick math there. The volume of this is 350 inches cubed. So each brick is going to use up 350 cubic inches of this concrete. So if we have 14,000 cubic inches of concrete and each brick uses 350, then 14,000 divided by 350 is 40. So the company is going to make 40 bricks if they use this much concrete and make it by this dimension. Okay, so there's all kinds of applications that we can do, but there's some basic few to start with. Okay, they can mix it up, they can use different shapes and ask surface area volume for them, so make sure you're reading it carefully, writing down work that goes with it. All right, I'll let you get at it.